This week we're going to start Topic 2, Lesson 2, Minerals, which can be found on pages 60 through 68 in your textbook. Defining minerals. What is a mineral? It is a naturally occurring solid that can form by inorganic processes and has a crystal structure and definite chemical composition. They are formed deep beneath Earth's surface, and there are 5 characteristics that define a mineral. Are they naturally occurring? They're solid. It forms by inorganic processes. It has a crystal structure, and it has a definite chemical composition. Now we're going to look at Figure 1, Mineral Giants, on page 61. I'm going to read you what it says. Dwarfed by megacrystals of the mineral selenite, miners explore Mexico's Cave of Crystals, located about 300 meters below Earth's surface. The cave contains some of the largest crystals ever discovered in nature, up to 12 meters long. Now that we've done that, we're going to look at the Connect It on page 60 in our textbook. It tells us to circle 2 crystals in the photo. So if you look on page 61, there are lots of crystals that you could circle, and any of those would be fine. All right, now let's look at the question. Do you think these crystals formed in conditions that were stable or that changed often? Explain. So based on what we know about crystal formation so far, and about the properties of caves, we're going to say that because they are so large and underground, the crystals probably formed under conditions that were stable for a long time. So if any of you ever go into a cave or any place that's underground, you'll know that the temperature is pretty stable there. And that alone is a good sign that the environment itself is also stable. Mineral properties. Geologists have identified and named more than 5,000 minerals, though only about 20 make up most rocks of Earth's crust. Each mineral has characteristic properties that can be used to identify and describe them. We're going to go to page 62 and 63 to see some examples. We are also going to talk about the different ways that we can identify them. So we have the streak. The streak of a mineral is the color of its powder. Although the color of a mineral can vary, its streak does not. Color. Minerals come in many colors. Only a few minerals have their own characteristic color. Luster is the term that describes how light reflects from a mineral's surface. Terms used to describe luster include metallic, glassy, earthy, silky, waxy, and pearly. Density. Each mineral has a characteristic density or mass in a given volume. To calculate a mineral's density, use this formula. Density equals mass over volume. Cleavage and fracture. A mineral that splits easily along flat surfaces has the property called cleavage. Whether a mineral has cleavage depends on how the atoms in its crystals are arranged. Most minerals do not split apart evenly. Instead, they have a characteristic type of fracture. Fracture describes how a mineral looks when it breaks apart in an irregular way. Crystal structure. All the crystals of a mineral have the same crystal structure. Different minerals have crystals that are shaped differently. Geologists classify crystals by the number of faces or sides on the crystal and the angle at which the faces meet. Hardness. The Mohs hardness scale is used to rank the hardness of minerals from 1 being the softest to 10 being the hardest. A mineral can scratch any mineral softer than itself, but can be scratched by any mineral that is harder. Special properties. Some minerals can be identified by special physical properties. For example, calcite bends light to produce double images. Other minerals conduct electricity, glow when placed under ultraviolet light, or are magnetic. So the rock we are looking at on this page is pyrite. Under the chart on page 62, you'll see the identifying minerals. So you can identify a mineral such as pyrite by its properties. Describe the color and luster of pyrite. Now that we know what all of these terms are, let's go ahead and look at the color and see what we would define it as. In technical terms, we would more than likely use the terms golden to brassy yellow to describe pyrite. The streak has been labeled for us because we wouldn't know that. Now luster. The luster is going to be metallic for pyrite. We can also see the hardness, density, crystal structure, cleavage or fracture, and special properties all listed in the chart. And now we're going to look over on page 63 and we're going to do the math toolbox. And we're going to go ahead and try and calculate density. So a sample of the mineral cinnabar has a mass of 251.1 grams and a volume of 31 centimeters cubed. What is the density of cinnabar? So we're going to use our equation that we just learned, density equals mass over volume. If the mass is 251.1 grams and the volume is 31 cubic centimeters, we're going to divide 251.1 by 31, which should give us 8.1 grams per cubic centimeter. Mineral formation. Minerals can form in a few different ways, and they can form at or below Earth's surface. Organic minerals are formed from some living things. Example, our bones and deer antlers are mostly made of the mineral calcium. All minerals can form by inorganic processes, but these can form by organic processes as well. On the bottom left-hand corner of page 64, we have an academic vocabulary section. So you might be familiar with the term organic food. How does this meaning of organic differ from the scientific meaning? Organic food is food grown without chemicals. In science, organic refers to material that is living or comes from living things. So that would be our difference. Now we're going to continue on with mineral formation. Minerals can also form from solutions. This means that elements and compounds that form minerals dissolve in water and form a solution. When water evaporates, it leaves behind minerals that previously were dissolved in the water. Crystallization is the process by which atoms are arranged to form a material that has a crystal structure. Mineral formation continued. Minerals can also form from magma and lava. The slower the magma cools, the larger the crystals are formed. Slow cooling magma forms quartz, when fast cooling magma forms basalt. Fast cooling magma will have air pockets when it hardens, when slow cooling magma has no air pockets. So now we're going to do the figure 3 activity on page 64, 65. So, where minerals form. Minerals can form by crystallization of magma and lava or precipitation of materials dissolved in water. Circle the area where you might find a cave with crystals similar to the large crystal shown in figure 1. So an area like that would be around the point close to lava where minerals formed in solutions and by evaporation goes to. So The minerals that are formed in solutions and by evaporation, some examples of that are halite, calcite, and gypsum. Underneath that, there are minerals formed as lava cools. So some examples of those are pyroxene and olivine. Minerals formed as magma cools are quartz and feldspar. We're going to go ahead and do our reading check on page 65 as well. So summarize text. What type of minerals might a geologist expect to find near the site of an ancient lava flow? Explain. Pyroxene and olivine, because both minerals can form as a result of lava cooling, as we just discussed in our figure 3 under minerals formed as lava cools. A change in temperature or pressure can alter one mineral into a new mineral. Diamonds and graphite are both made from pure carbon. These two items are very different. We're going to use figure 4 on page 66 to help. So diamonds need a lot of heat and pressure to form. Which type of rock would we find diamonds in? So we're going to look at figure 4. Immense pressure and heat in Earth's mantle compacts graphite into diamond. Why do diamonds only form in certain spots in the mantle? And the reasoning is because intense pressure is required for diamonds to form. So the type of rock that we find diamonds in is going to be graphite. Not all graphite will turn into diamonds because we have to have the right circumstances. We are going to go ahead though and move on to the model it on page 66 about diamond formation. We're going to use the information in the text and in figure 3 to draw a diagram that shows how diamonds form. Your model should show and label the following parts of the process. 1. Graphite in the mantle that is under intense pressure becomes diamonds. 2. In the past, magma from the mantle moved quickly toward Earth's surface, forming pipes. The magma cooled with the diamonds trapped within it. So go ahead and draw your diagram to the right using figure 3 on page 65 to help form that. And your diagram should show graphite forming diamonds in the mantle and then the magma carrying the diamonds up into the crust. Mineral distribution. Minerals that make up the Earth's crust are more commonly found. However, this is not true for all minerals. Minerals that are rare or harder to find probably need more time to be created. These minerals need more time, specific materials, and certain conditions in order to be created. So we're going to go ahead and do the reading check on page 67. Integrate with visuals. What ideas from the text are illustrated in the map in figure 5? Some minerals are very rare. Some minerals are tied to geological processes, so they are found in concentrated deposits in specific places. Now we're going to go ahead and do the explanation and everything that goes along with figure 5 on page 67. So the map shows the location of some important mineral resources. Many of the minerals represented on the map are not evenly distributed across the planet. What patterns do you notice in the distribution of different minerals on Earth? So, an answer that you could have is some areas on Earth seem to have a larger concentration of different minerals than other areas. Northern, Western, and Southern Africa, for example, have many resources which are not found in Eastern Africa. Something else that I noticed while looking at it is that a lot of the minerals are found closer to coastlines. And based on the information that we've learned about everything else, what can that tell us? So that is the end of lesson 2. So now let's go ahead and do the lesson 2 check in the book together. So 1, What are some of the properties that geologists use to identify and describe minerals? If you'll remember on page 62 and 63, we discussed that geologists describe minerals based on luster, streak, color, hardness, density, cleavage, fracture, and structure. Question 2. Why aren't diamonds found evenly distributed on Earth? If you'll remember on page 66 when we were talking about diamonds, the reasoning is that the process that forms diamonds requires specific conditions. These conditions are not found evenly across Earth. Therefore, you cannot expect to find diamonds evenly distributed in Earth. Question 3. Amber is a solid material used in jewelry. It forms in nature only by the process of pine tree resin hardening. Explain why you think amber is or is not a mineral. So amber is not a mineral, and it forms only from organic processes. In order to be a mineral, it must also form from inorganic processes. Question 4. What role does the sun's energy play in the formation of minerals from solutions? So energy from the sun can cause water to evaporate. Minerals dissolve in the water, will be left behind when the water evaporates. And then 5, draw a flow chart or cycle diagram to show one way a mineral gets recycled in nature and forms a new mineral. So something that this should include is, or something that it can include more accurately, is that water dissolves elements and compounds in a mineral, the solution evaporates, and then a new mineral crystallizes. If you would like to draw a model of another way that we can get crystals, you can absolutely do that and then come get it checked by me. All right, we're going to go ahead and do the quest check-in on the last page under the lesson check as well. So in this lesson, you learned about minerals and the processes that result in their formation. So we're going to work on constructing arguments. Suppose a director filming a science fiction film wants to include a scene in which the hero and heroine travel down inside Earth to stop a band of criminals from stealing Earth's supply of diamonds. As the science advisor, what advice would you give the director? A very simple response to that would be no human would be able to withstand the pressure and heat, so I would suggest that the scene not be filmed. Now, if you wanted to film the scene, what kinds of things could you do in order to cover that? Can you think of anything? Go ahead and write your answers down and then come show me in class. Now that everything's over, you have time to work on your rock and mineral comic. You also have time to work on your density worksheet and everything else that we have. The link to this page is a video for an example of a really good rock comic. Your rock comics, the paper says that it should be 12 comic strips long, but I only need you to do 10. If you want to do more, awesome. If not, that's okay too. Make sure you get your 10 done though. I will help you in class as needed. Let me know if you have any questions.